Hello, my fellow YouTubers. This is Roy back again. Let's go over this setup here so I can show you guys at home how to make the perfect oscillator. You're going to need a couple things. You're going to need power supply, DC, power supply, DC. You're going to need a spark gap. And when you go to make, I got this from a buzz box. Pretty much, it's a great spark gap. And then I modified the front so it could be adjustable. And the next thing is you need a core. Here's the buzz box core that they give you. That's little pins, sort of like tiny welding rods, about 6 inches long. And then I took the windings off of the coil that was on here, and I put 16 gauge wire. And I could say a couple things in reference of the coil. Here's another coil. This one's a bifilar, and this one I have the laminate steel. So I have that to where the core can go inside. I push it forward, try to get it close in proximity. And just this one itself, we'll fire this one up first, and then we'll talk about it, then we'll fire this one up. This one's specially designed, and we'll go over that. It involves eddy currents and limiting the current. I need something to put in the back here, so I guess we can just use that. So pretty much we're looking at power, spark gap, core, coil. We don't need the bifilar to run this setup. If you notice that this is a single core, I guess we'll start with the single core. One is because it's specially designed to knock down the eddy currents, and that has something to do with the laminate iron bars inside, but also how this is wound, because I start the winding here and I wind it, and this one is in a rotation this way. I get to the end and I pull the wire all the way back, which you can see the wires in there, and then I wind it the opposite way. Then I come to the end, then I pull the wire all back, and then I wind it the opposite way. So what we're doing is magnetically locking in the magnetic field, so the field's not expanding out, it's pushing inside. We'll go over why we're doing that. So we're going to put that core in there as well. We'll put it close. We'll set it on there. And we're going to use both batteries, so we'll come out of the positive, go into the negative. And that'll give us, these are 12 volt batteries. That will give us 24 volts and then some. So we're coming out of the battery on the negative side, and we're going to go into the, I'm going to put that right here. And that is connected to the outside part of the spark gap. We're going to come off the positive side, and we're going to go into the part that I have as the start right there. Now we're going to use one more, and we're going to connect the bottom part of this spark gap, which is connected to the inside part there of the gap. So both sides are connected. Now when I connect this, we should have make adjustments here. Notice I made this very adjustable. Being very sensitive right now. I don't give up. Single wire. Now, obviously the 16 gauge don't have a lot of resistance, so you don't want to run it a long time on that. That's core number one. That was a little long for that one. So now let's go into this one, which is a bifilar. And on this one, remember, this has no transistor, no capacitor. It's how it's wound is the important part. So remember, we're coming out of the positive, and this time we're going to pick the smaller wires. Well, we'll pick the bigger wires. Now the smaller ones. Just the start one. Get the positive. We're going to come out of the positive. In the end of the wire, we are going back around. Goes your oscillator. Now let's go ahead and change the wires. So now we're going to go to the fatter wire. Of course, I made this adjustable. The fact that you're changing DC, or I mean DC, into pulse. Very sensitive. So that's why it's, last night I showed you on that coil, not to mention the effects from the magnet. I think my cables are, let me switch the positive and negative. So the positive is coming in and going there. The negative should come out and go to there. See if we get different results. Yeah, I don't like those results. So we come back out of the positive, go into the switch up now, go to the end of the coil. Or heck, let's just go back over here to the Bedini. So it's situated and set up there. It's easy to show the demonstration. So we're going to come off. We're going to connect the positive and the negative on the battery. We're going to come out of the positive side, and we're going to go, where's the other thick one? Guess that's it, huh? Coming out of the tail end into the base part of that spark gap setup. And then we're going to come out of the negative and we're going to go right into the side here. We're going to move the magnetic field away. No, something not right. I see spark. It's on. I wonder if I burned out the contacts. I have to melt some silver on them. Alrighty. Well, you can see that I took you through three different coils. Looks alright. I bet it might be the jumper cable or something. That's a little weak. That's surprising. Let's go back over here. I'm not going to use those cables. Nor am I going to use these batteries. Might be junk. We'll go to these batteries. Change to some other wires. So we're jumping the positive to the negative on the battery. You guys that build these at home, just get any coil, wind it up, single coil. What I would do is this. Since you're pulsing, you can handle a lot more voltage and current. But if you design the coil, so if you put the 24 volts that's going into it to where you can just have both ends connected and the coil itself doesn't overheat, you know you have the perfect design coil. Now when you go to pulse that, you can probably go up double the voltage, if not just a little bit less. That means you can pulse 48 volts through that and the coil won't even feel warm. It's because why? You designed the coil properly. Alright, so let me see. What are we looking for here? Got all of our parts, right? Alright, so we are going to go back to, let's go back to the bifilar. And this should just fire the hell up. Alright, so you got the jumper. We're coming out of the negative. That should go to the bottom, I think the way I had it. And then the positive goes into, let's go into thin wires so we don't, we'll go in the thicker ones. We'll get a little bit more current with the thicker ones. So we're going to the fat wire there. And we're going to come out of the other end of that. And we're going to connect that to the bottom section of this spark gap array. And that's pretty much it. I'm coming out of the negative into the front part of that spark gap. Pretty interesting, huh? So now we're pulsating that voltage in the DC through just a regular coil. Very sensitive. You have to have it on a stand where it's fixed. You're dealing with vibrations. All right, guys, leave your comments. 22 minutes on how anybody can make a DC pulse oscillator. Not many components. There you go. All the parts you need to make an oscillator. Enjoy, guys. Have fun with them.